Right. Welcome to this video that I am calling Explaining the Meme. This is a kind of a maths tutorial kind of thing. Because I was on my sofa scrolling through Instagram and I saw this meme that's kind of going around right now, but applied in a math context. I thought it was very, very clever. A really funny use of the meme, and then I thought, how can I prove this? So I thought I'd look it up, have a bit of a mooch around, and then I thought, well, I've not got much to do, so I'll make a video on it. This is the meme in question, posted by juicy_mathematical_memes. It says, I'm going to prove that 3 multiplied by the sum from 1 to infinity of 1 over 2 to the 2n equals 1. Algebraically, right? And then it tends to just repeat this process. I'm going to prove algebraically right, and then it just goes on and on and on. And I thought this was quite cool, and I don't think I've actually seen a nifty little proof for this. I thought I'd have a go at it myself. So if we actually write what what we're looking for, so we're looking for 3 multiplied by the sum of 1 to infinity of 1 over 2 to the 2n. We're looking for this, and we're looking to prove that it equals 1. Okay, so if we look at the image itself, we've got 1/4 here, we've got 2/4 here, we've got 3/4 here. So the first thing we have is 3/4. Next thing we have, because this quarter here is then split up into quarters, so we have 16ths. So we have 1/16, 2/16, 3/16, and then it's split up again. So we now add, that's not a very good add, eraser. Pen, add 3/16, and then we go on. This is then split up into 64ths, 3/64ths, and so on. And the last thing you get is, surprisingly enough, 3 over 2 to the 2n. That last term. If we bring out the 3 as a common factor, we have 1/4 plus 1/16 plus 1/64 plus ... as it tends to the last term, 1 over 2 to the 2n minus 1 plus 1 over 2 to the 2n. So if we go back to here, that's essentially the sum that we're looking for. Let's focus on this bit though. And first, I'm going to use a method that is primarily used to show the sum of 1 over 2n. So if we look at that as a completely different thing, so the sum of 1 over 2 to the n. So we're looking for 1/2 plus 1/4, because where n is 1, we have 1/2, n is 2, we have 1/4, plus 1/8 plus 1/16 plus ... plus 1 over 2 to the n minus 1 plus 1 over 2 to the n. So what we're going to do now, we're going to give this a name. We're going to call it something. Let's call it s to the n. We're calling it the sum of all the n terms. So Sn equals all of this. What we're going to do now, we're going to multiply this by 2. So if we multiply by 2, if we anything we do to the left, we've got to do to the right. So 1/2 multiplied by 2, that's 1. 1/4 multiplied by 2 is 1/2. 1/8 multiplied by 2 is 1/4, and we just go on and on and on until we get to this term. 2 lots of this, where we just subtract 1 from the bottom power, because we're dividing both by 2. 2 to the n minus 1 divided by 2 is 2 to the n minus 2. So we have 1 to the 2n minus 2, and then we have 1 over 2 to the n minus 1. This term here is somewhere contained in these dots, so it is part of the sum. Now, if we look within this term, we actually have most of our Sn, because our Sn starts at a quarter, ends at 2 to the n. This, however, ends at 2 to the n minus 1 here. So if we take this, we can say that this equals 2 to the Sn. However, we don't have the 1 over 2n, and we also have this 1 here. So there are two terms that we are neglecting. We're neglecting this first term, and we're neglecting this last term. So we can say that all of this here equals s to the n, subtract our final term, which is 1 over 2 to the n. Ignore that for a second. So if we rewrite this out, we have 2 to the Sn equals 1 plus 1 of Sn minus 1 over 2 to the n. We can tidy this up by bringing all the Sns to one side. 2 lots of something, subtract 1 lot of something is just 1 lot of something, so the sum of n numbers equals 1 minus 1 over 2 to the m. And then finally, we just say that because this sum is approaching infinity, we want to say that what does this thing here, what does this tend to? And the word tend, what does it approach? As n gets bigger, what does the value of this fraction become? Say, if we're making the denominator larger, but we're not doing anything to the numerator, then it's going to become infinitely small. And a number that's infinitely small, we basically just call 0. So we say, as n tends to infinity, 1 over 2 to the n tends to 0. So here we are just going to say that Sn equals 1 minus 0, which equals 1. And that is our way of saying that the sum of all these numbers equals 1. However, that's the concept. Pause it if you need to look over again, or just rewind. I'm going to erase everything on this slide. I'm also going to erase everything here. Let's just get rid of all this, because we're not actually looking for the sum of 1 over n. We're looking for the sum of 1. We're not looking for the sum of 1 over 2 to the n. We're looking for 1 over 2 to the 2n. Let's take a little while to rub out. And there we go. So let's do what we did last time. So we want the sum of these numbers, 1 over 2 to the 2n. Now let's just plug in the first few numbers. So when n is 1, we have 1 over 2 to the 2 to the power of 2, which is 4, so we have 1 over 4. Plus, when n is 2, 2 times 2 is 4, 2 to the power of 4 is 16, so we go 16. And you'll just be able to see that these are just 4 times 4, and then the next number will be 4 times 4 times 4, which is 64, and so on, all the way to 1 over 2 to the 2n minus 1, and then finally 1 over 2 to the 2n. What we're going to do, we're going to call this something. Again, we're just going to call it Sn. And now we're going to multiply Sn by 4, this time instead of 2. So we're going to say that 4 Sn equals, now 4 quarters is just 1, 4 sixteenths is a quarter, 4 64ths is 1 16th, and so on and so forth, all the way to 1 over, let's do that line a bit less long, and let's actually stay on the slide, 1 over 2 to the something. Now, because we're multiplying it by 4, this 2 power, so we're multiplying the top by 4, it's going to be subtracting the 2 from this power, because 2 to the, we want to cancel this bottom term by 4. 4 is 2 to the power 2, so we're getting these things with the same power, so we can do some subtraction. 2 to the 2n minus 1 divided by 2 to the power 2, we can just subtract, and we're left with 2 to the 2n minus 3, and then the next term along is just 1 up, 2 to the 2n minus 2. So if we evaluate this, we have a part of this new sum which is identical to our old sum, so we have this here. Except we have these two terms at the end which aren't included. So if we subtract these from both sides, minus yada yada yada, we now have just this term here, which is what we're looking for. So we can replace this here, 4 to the Sn equals 1 plus Sn minus 1 over 2 to the 2n minus 1 minus 1 over 2 to the 2n. We go to our next slide, just so we got a bit more space, and we tidy that up. We're going to bring this Sn over to this side, so we are going to have 3 Sn equals 1 minus 1 over 2 to the 2n minus 1 minus 1 over 2 to the 2n. Now again, we want to say, what do these two things tend to? Because our sum is going to infinity, we say that our n is also effectively infinity. So what is 2 times infinity minus 1? Well, infinity you can't really do anything to. 2 times infinity is 2 times an infinitely large number is still just an infinitely large number. And an infinitely large number subtract 1 is still just an infinitely large number. So we just say that it approaches infinity as 2n as n approaches infinity, 2n minus 1 approaches infinity. 2n also approaches infinity. These two fractions here then, so we have 1 over effectively infinity minus 1 over effectively infinity. 1 over infinity we just say is 0. So we have 1 minus 0 minus 0. These things just cancel out. So we now have 3 to the Sn equals 1. Sn therefore equals a third. We were looking to show that this sum multiplied by 3 equals 1. Well, that's what we've done here. We've just said that 3 lots of the sum equals 1. And because Sn was our replacement for the sum of 1 over 2 to the 2n from 1 to infinity, therefore we can say that 3 to the sum 1 to infinity of 1 over 2 to the 2n equals 1. And that is the meme explained. I hope that was helpful. Thank you for watching, and I'm sure I'll make another video at some point. Thank you, goodbye.